This video covers the first in a group of Core 3 lessons on functions, specifically enabling you to be able to identify the domain and range of functions. We're going to do that by example. So I'd like you to have a good look at this graph. If you look at the bottom here, you can see it says domain. Domain is essentially the x values or input values for a function. It then says x, and a funny little symbol here looks a bit like the euro sign. That symbol means member of a set of. So it's saying that the x values are a member of the set of, and then this that looks like IR is actually a strange looking R, and it stands for real numbers. We'll go over this a bit more in the lesson when I can draw it out a bit better than this, but it's x is a member of the set of real numbers. It also states here that x is greater than or equal to -5 and less than 7. You'll see the filled in circle here means that it can be equal to -5, whereas the open point there means that it can't be equal to 7, but anything below 7. So have a good look, make sure you understand that. The domain is that x is a member of the set of real numbers, it's greater than or equal to -5 and less than 7. Now what's the domain of this? I'll pop the answer up in a minute, but have a think about it and see if you can do it for yourself. Okay, is that what you got? Next one. Okay, hopefully you got that. If you're still not getting them, maybe go back to what I said a couple of slides back. Go over that again. This one. Okay, so remember it's equal to -6 and equal to 6, as well as being in between -6 and 6 because of the filled in points, the closed points as we call them. What about this one? Okay, and that's what you should have got. So to sum up, the domain of a function is a description of the values of x for which it is to be defined. There are various reasons that a function may only take limited values. For example, it may be impossible to evaluate the function for certain values of x. It may be we're only interested in particular values. And sometimes x can't be negative, like for example if x represents time. Sometimes we have what we call infinite domain. So the way we'd describe this one is that again x is a member of the set of real numbers, but x is greater than or equal to -5, but it can take any value greater than or equal to -5, so we just put this inequality here in. Okay, have a good look, make sure you understand, and then there's a few for you to try to follow. Okay, did you get that one? On this one, x is a member of the set of real numbers and x is greater than 2. Notice the open point here, so it's got to be greater than 2, not equal to. Okay, that's what you should have got. And what about this one? Confusing, isn't it? Well, this is what you should have got. Just simply, x is a member of the set of real numbers. It can take any value, any real value, so we just write this here. The bit in bracket is just by way of explanation, but you don't necessarily need to put that. For domain, you can simply put this. Here's some special functions. This is a bit of the graph y equals root x. Now, because we can't square root a negative, we would need to state for this function that x is greater than or equal to 0. So for this we just have x is greater than or equal to 0. When we have y equals root x, then we just take the positive roots. We don't consider negative roots. So we would put this. Another one that you should probably know, y equals 1 over x, well, we have an asymptote here at x equals 0, the y-axis. So what we would put for the domain here is that x can be any real number except 0. So we would have to state that x doesn't equal 0. Right, next we'll do the same with range. Have a good look at this one. We've got the range here between 0 and 25. Don't be fooled by looking at the x's like we were doing before. We're interested now in the lowest y value and the highest y value. Now that's an open circle, so that means it can't equal 25, but actually this point here, that's just the origin. A little bit confusing. It's not the end of the curve, is it? So that O there just means that's 0, 0. And at that point, y does equal 0. So we would state that 0 is less than or equal to y, which is less than 25. In other words, y lies between 0 and 25, and it can equal 0, but it can't equal 25. And you can probably tell from this that it's actually part of the parabola y equals x squared. Notice we don't state that y is a member of the set of real numbers. We don't really need to do that for range. So have a go at this one. Okay, again be careful here, don't get drawn into these points. It's the minimum and the maximum you're interested in. Although it's an open point here at -2, because it's closed here, it does mean that at this point -2 is included. So we would have -2 is less than and equal to y, which is less than and equal to 2. Okay, this one's slightly confusing. Again, look carefully at the graph. Notice it's an infinite range in that direction. So that means that a bit like we had with the domain, we have y is greater than a fifth. Well, that's that point there, and it's an open point, so it doesn't include that y value, and then it just goes on. So anything greater than a fifth. This one, another parabola, again goes off to infinity, so it's only the minimum point we're interested in, that it's greater than, and there it's greater than and equal to 3. So to sum up for range, the range of a function is a description of y values, output values for which it's defined. And again, like with domain, there are various reasons it might be limited. For example, we can't have a squared number that is negative. And like with domain, we might only be interested in certain output-input values. Okay, try the quiz now.